Okay, this is a walkthrough of the Chemistry High Level Paper 1 done back in November 2018. This was used as our 2024 Year 13 PPE. So I'm going to walk through 10 questions at a time, including questions that you were asked not to do, starting with question 1. So question 1, you're given a balanced equation. You're told to work out how many moles of this stuff, FeS2, required to produce 32 grams of this stuff here, SO2. Now, to work out the number of moles of something, you do the mass over the MR. The MR of the formula mass of SO2 is 32 at 16 and 16, which is 64. The number of moles of SO2 is equal to 0.5. So therefore, the number of moles of this stuff required was half that amount, which is 0.25, and that's our final answer. So that's question 1. The volume of a gas at 27 degrees C is 10 decimeters cubed. What's the temperature when the volume is reduced to 9 decimeters cubed? And this is an example of a question which looks easy on the face of it. It is straightforward, but you can't just assume you can do this in your head without thinking. You don't actually need a calculator for any of the pre-2023 papers, because paper 1 was a non-calculator paper. No, nevertheless, you'll still have to do some working out. So if you've been given a temperature and a volume and another volume, you need to know the relationships, the gas law relationship. So you should know that V1 over T1 is equal to V2 over T2, and it's that we're going to use to solve this. So remember those relationships: P1 V1 over T1 is equal to P2 V2 over T2. Just cross out the ones you don't need. So we're going to rearrange this to make T2 the subject of the equation. We want T2, so that can come up here, V1 can come down here, T1 can come up here. If you can't do this rearrangement, you need to practice this. This is relatively straightforward, I would say. Whoops, he says messing it up. So V2 over V1 times by T1. Okay, that's what you have to do. So T1's gone up from there up to there, T2's gone up to there, and V1's come down to here. So you plop the numbers in. You've got new volume of 9 and the old volume, the original volume of 10. But then you've got to do a little bit of thought, because this only works, these gas laws only work. This is done in Kelvin. 27 degrees C is 300 Kelvin. Nice easy number to work with, times 300. So it's 9/10, 90% of 300, which is 270, which is the same as minus 3 degrees C, right? Okay, an antacid tablet with half a gram molar mass of that in that volume, what's the concentration? Okay, so first of all, we've got to work out the moles. So we're trying to work out concentration in moles per dm cubed. So the concentration is moles divided by per dm cubed. Right, so let's work out the number of moles first by doing the mass over the MR, and so that's 0.5 over 84, so 0.584, so it's going to be one of the ones that has that in there somewhere. And then we've got to divide per dm cubed to divide by the volume. The volume is in decimeters cubed 0.250, so, and that answer is B. This is a question about facts you simply must know, but I'm just going to do a little reminder of what this would look like. So if you're ever asked to draw emission spectrum, please draw the energy line there, and you've got the different lines: n equals 1, n equals 2, n equals 3, and they gradually converge, they get closer together as you get higher up to n equals infinity, n equals 4, and so on. Right, so as you can see, I've drawn it so that the lines of the energy levels are converging as you get higher in energy. If you get higher, frequency and energy are proportional. So the higher the energy, the higher the frequency. The lines converging at higher energies is, of course, right. And you might remember that hydrogen, its ground state is an electron down here somewhere. What happens if you heat it up? Give it some energy, that electron can move up to here or up to here, up to here, or whatever, and eventually it will drop back down again. And it's those electrons dropping from high energy levels to low energy levels, or lower energy levels, that releases energy. Those that drop to n equals 2 are the ones that release light energy, and you're expected to just know that. That's just a fact you're expected to know, so that's true. And I've already said this, but the lines produced when electrons move from higher to lower. This is saying lower to higher, so that one's wrong. So the answer is A there. Values for ionization energies. What have we got here? So for two elements, X and Z, I'm looking at these numbers straight away and I'm just seeing a massive gap between there and there. And I'm looking here, there's not an enormous gap anywhere here. So given there's a large gap between there and there, this is telling me it must be a group 1 element. So it has to be either, well, it has to be lithium for X, and there's no really significant gap. I mean, that's kind of going up by a couple of thousand, it's going up by a couple of thousand. There's no major difference between any of these. So this is going to be, this must be B, which is carbon. So it's this one here. Carbon is in group 4, so there'll be a big gap between 4 and 5, and beryllium is in group 2, isn't it? Beryllium's in group 2, so there'd be a big gap between second and third, so that's why it can't be beryllium, so it's B. Which oxides produce an acidic solution when you chuck them into water? A relatively easy question. You should know that oxides of non-metals will give you oxides of non-metals will give you acidic solutions. That's something you would know. So that applies to this one, this one, this one, and this one. And so it's those. Aluminium oxide, well, it's a metal oxide, but importantly it's completely insoluble. And you should certainly know that silicon dioxide, silica, is completely insoluble. That's sand. If sand was soluble, we wouldn't have any beaches. So it ain't that. So the answer is whichever 2 and 3 is, which is C. And then question 7, which requires the least energy for the removal of 1 electron. So that's just worth thinking about a minute. So just get your periodic table, wherever one of those is. We've got... So you can see what I've just quickly done there is work out the number of electrons each of them have. So sodium ion, 1 plus ion would be 2,8, magnesium 1 plus would be 281, so would Al 2 plus, C3 plus would be 2,1. So electrons easiest to remove are going to be ones in the third shell, so it either has to be B or C. So which of those is going to be easiest to remove? Well, the one with the least number of protons, and magnesium has 12 protons and aluminium has 13. Which is why the answer is B, the magnesium 1 plus ion. So easy to work out, but you have to think about it. These answers don't just fall out typically. Which is correct for the complex ion FeCl disulfate? So we've got a 1 minus chloride ion that's a ligand to the Fe. We've got, so that overall species in brackets there is must be 2 plus, because we've got a 2 minus ion on the outside, and because this is 1 minus, this must be 3 plus, so the ion there is 3 plus. So it either had to be C or D, the possibilities at the moment. And the overall charge of the complex ion, I've just worked that out, it's 2 plus because it's got a 2 plus sulfate counter ion, so that's the answer, D there. Which species has the same molecular geometry as SO3 2 minus? Now you'll have to work this through carefully. Now SO3 2 minus is remarkably similar actually to the bromate ion I was drawing in paper 2, so you might have looked at that. But there are 3 bonding domains and 1 lone pair on the sulfur. I'm not going to draw it, and you can quickly look that up if you want to. I've got no will draw it, I'll just pause. And amusingly I messed it up, which was good fun. So we've got 1, 2, 3 bonding domains. We've got 1 lone pair, so that's the same as ammonia, and PF3 will find exactly the same. The others don't. So you might have to sketch this out, work them out, and they will take a little while to do. You don't expect paper 1 questions or the multiple choice questions to be a breeze. You have to work them through carefully. I just realised I kind of rushed question 9 a little bit because I'm hungry and I can hear that dinner's nearly ready. But yeah, you would need to draw all of these out probably to work it through. So I'm going to help you a little bit more with CF2 to do this one properly. So it's ClF2 plus. So the first thing to do is just to work out the number of electrons there are in total, valence electrons. So chlorine has 7, this is in group 7. There's 2 fluorine, so it's 7 add 7, which is 14, which comes to 21, but it's 1 plus. So in total there should be 20 electrons. So make sure when you're checking at the end you've got 20 electrons. Fluorine is more electronegative than chlorine. So if it was a minus ion, a fluorine would have the minus charge. But chlorine is more electropositive, so it's that we're going to remove an electron from. So we're going to give the chlorine 6, if I can draw 6 electrons, and each fluorine is going to have 7 electrons. I don't know why I drew it like that, that's a bit rubbish. I'll start again. So chlorine, we're going to give it 6 electrons, 2, 4, and then 1 there, and 1 there to make bonds with fluorine. I've drawn an extra electron again for some reason. It should be 6 around chlorine, like so. And one of those electrons is used to make a bond with the fluorine, therefore making fluorine have a full outer shell, and then we're going to do the other one the same, fluorine's full outer shell there. So 8 electrons around fluorine, 8 electrons around this fluorine, and the whole thing has got a 1 plus charge. Just tot up the electrons to make sure you got the right number. So 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18, 19, 20. We've got 2 bonding pairs and 2 lone pairs around the central chlorine atom. So the answer is D, and that's me done for questions 1 to 10. Hopefully that was useful.